Hello, today we will see simulation. Here I'm having software TINA, that's of Texas Instrument software. Here we have different options like basic, switches, meters, then we have sources, semiconductors and some spice models as well. So here from basic you can see I have resistors and everything. Today we will go for the BJT. Here I have taken NPN transistor. Okay, so if you double click on that, you can see we have number of options. Okay, so yes, you can check here like we have 2N, 2222. You have BC547. As BC547 is very commonly used, we will go and select that. So all the characteristics that BC547 is having will be selected. Okay, I'm clicking OK and OK. Yeah, that's it. My BC547 has been selected. Here I'm making one voltage divider, right? So I'm connecting it in a voltage divider biasing, and RC, RE I will connect here. And one input signal, that is AC input signal, I'll give to the transistor and will take amplified but inverted amplifier signal at the output. So yes, you can see I have connected R1, R2 and again R3. It's basically RC and RE. Okay, so right now I'm not changing any value. I'm keeping all the resistors to 1K only. Okay, I'll connect all the components here and give VCC. Here you can't directly give VCC by just a one probe. Here you have to give the battery for the VCC, okay, with respect to ground. So this is how I have connected voltage basic. This is my coupling capacitor I'm placing at the input side and again another at the output side. Right now the values are selected are only 1 microfarad, that are the standard available here. I have connected one CE here and that is also again 1 microfarad right now. I'm not changing any value over here. Okay, we will see how transistor will respond for these values. Okay, so here I have connected RL and that RL will be 10K. I'm changing that value of RL and connecting it between RC and ground. Here, so value I have changed and that RL. We have done with it. Right now, the task is I have to give VCC with respect to ground, and another point is I have to give AC input signal. Okay, for the RCE, I have changed value to 100 nanofarad. Okay, so these are not calculated values. These are just random values I'm giving. 100 nanofarad for input coupling capacitor, 100 nanofarad for output coupling capacitor. Okay, so here you will see like our graph for frequency response. What is frequency response? Basically, transistor will react stable. Like gain of the transistor, we will get stable for the range of frequency. And that should be infinite in ideal cases, but yes, in a practical cases, it should be high. Okay, so our gain should be stable and that we need to see. Here I have connected VCC with respect to ground. And yes, we have almost done with the circuit. One common ground has been given and now I'm giving voltage generator. Okay, so we do have different options for the voltage generator, like what we need to give. Like we need to give step signal, square waves, sine wave and everything. Okay, so here I'm giving name V in and changing that to analog signal. Here, right now I'm thinking I should select it for 10 millivolt. Okay, because 10 millivolt will give you proper output. Otherwise, your transistor will go in a saturation and it will give you square wave at the output. So I'm just placing text over here because the properties of the voltage generator is not visible. So I'm giving text 10 millivolt 100 kilohertz. 100 kilohertz is a standard frequency or the frequency range I have selected. Okay, and yeah, I forgotten to select it for 10 millivolt. So I'm just changing that. Okay, that's it. We have done with it. And now I just need to change the value of VCC. Okay, I'm giving it 10 volt and changing the name. Okay, that's basically not necessary, but yes, go with the standard. And then I'm just now connecting output voltmeter in parallel with the RL. So where I'll get the output, and now I can see how my input waveform and output waveforms are amplified. But you can see that waveforms are inverted, 180-degree phase shifted. Why? Because NPN transistor is act as an amplifier but will give you inverting signal. Why inverting? And that is because of the load line. So we will see that in a next video. Stay tuned for that. Okay. So now just go for the transient, and here you can see like we have 10 microfarad signal for one cycle. So we will select here 20. You can see 2 complete half cycles. Red one is the output. You can see it is between minus 60 millivolt to plus 60 millivolt. Okay, and V in is are between 10 to plus minus 10 millivolt, right? And now the point is we will change the values of R1, R2, RC and RE. Okay. Okay, so here the value of capacitor CE, we have to change it to 220 microfarad. Then R1 will be 12K, R2 will be 2.7K, RC will be R390 ohms and RE will be 100 ohms. Okay, so here we have changed it, and now this is time to see the waveforms. So go to transient. Okay, and now you can see how the signal is perfectly amplified between plus minus 1 volt. You can easily see that. Okay, for more related videos, stay tuned. Thank you.